I'll give you guys and gals a second to get a refill. So let me ask while you're refilling, has anyone here heard or used forward chaining before? Is this totally, no, okay, I thought somebody would have used it. I'll give you some synonyms for it too. It's like expert system, rule-based system, forward chaining, forward reasoning. No bells at all? Okay, cool. There you go. So I just was afraid I'd come in here and there'd be someone who'd be like, you're lying. This is all made up. I'm no expert on it, but I'll at least tell you what I've learned. So, okay, let's get started then. So I'm Steve Schwarz, and thank you very much for having me here. I'm really missed coming to these meetings. There's a lot of good people here, and we always talk about good stuff and have a good time doing it too. So feel free to interject if I'm talking too fast, not making sense, whatever. If you have some suggestion. So Ernesto said, "What's the name of your talk?" I'm like, something about forward chaining. So I came up with forward chaining for fun and profit, since that's like a canonical sort of, classic story, right? So let's see if I can. Oh no, it's bad when your slideshow doesn't even start. That's not a good. That's failure at step one. Let's retry that. Okay. There we go. So what's forward chaining? So I used ChatGPT to get the right answer for this. So I figured it's only appropriate. I kept writing a lot more words, and it came up with a pretty succinct answer, which basically is you start with some data, some facts about the world. You apply rules to them, typically human-created rules. And then by applying those rules, you deduce new things about the world, and that might help you reach a goal you're trying to solve. So it's a little abstract, right? Well, here's the classic example. Like you have a bunch of facts about animals. So there's 4 facts. Animal 1 has feathers and lays eggs. Animal 2 has fur and has live birth, right? So given 2 rules, if you had a rule that says, hey, if an animal has feathers and lays eggs, it's a bird. And the other one is if it has fur and it gives birth to live young, then it's a mammal. So if you were to take those facts, run them against those rules, you would come up with some new data about the world, which is, hey, animal 1's probably a bird, and animal 2 is probably a mammal. So that's all we're talking about here. Nothing really any smarter than that, except hopefully people have spent some time crafting rules that are more useful than these, right? But given these rules, you now know more about animal 1 and animal 2 than you did before. So that might help you do something more powerful. So where are these systems used? Medical analysis, fraud detection is a big one. All the credit card companies use some form of this, plus a lot more, I'm sure, where they're saying every time you go to make a transaction, they're looking up to say, what has he done in the past? What's the balance? The easy stuff. But looking at, gee, all of a sudden this is maxing out the credit limit in one transaction. This person never spends that much. Maybe we should flag it, or it's some percentage of their balance. A classic one is recommendation systems. If you see like, 30 other people bought this if you bought that, right? So if you guys are in the e-commerce space, a lot of that is driven by rules. And traffic control, like in the real world, like stoplights, timing of stoplights on roads. They're typically based on a lot of rules so that they can dynamically adjust to the load in the street. And so I mentioned before, here's some synonyms that you may have come across for these, and they're all really the same kind of thing. So basically there's 3 pieces to this. You got your facts, you got your rules, and then some kind of an engine, typically called an inference engine, that applies those rules to the facts. And by doing that, you end up with some deductions, something new about the world. You can deduce something new about the world. So I think there's 3 key things why you might want to use a rule approach versus just coding a bunch of stuff, right? The bird and mammal one, you could have just coded some if statements, right, to figure that out. I think you could hire someone based on their ability to write those if statements. That would be sufficient. But the key thing is these rules can be applied multiple times. So you can imagine in our mammal and bird example, you could have rules that then go on to further deduce this bird is a sparrow versus a robin, or this mammal is a lion versus a cat. So by running rules and having more deductions, this animal is a mammal. Now maybe a whole set of different rules can be applied to further refine and deduce what kind of mammal is this, and so on. So the beauty of rule-based engines is the engine will keep applying rules until your goal is reached or till it's exhausted the rules. Right. The other one is rules modify the world. So you've got this snapshot. We just had our 4 little facts at the beginning of this, right? Now we've added 2 more. So now we've got 6 facts about our animals. And so each time a rule runs successfully, you can update the world. And probably more from an organizational perspective, so you can pull these rules out into a knowledge base. So the developers using this engine don't have to, it's not necessarily even compiled in. It's just a whole set of rules that someone smart about that domain can manage. They can add and remove rules, refine them, tweak them, and then you just call the engine and say, here's the world. What's it look like after you've inferred stuff about it? What promotion should we give this person who just put something in their shopping cart based on what we're trying to push, right? You can imagine a rule-based system looking at your inventory levels in real time and saying, oh, we've got a real lot of green St. Patrick's Day t-shirts. We got to push these right away. Free t-shirt with every order over $20. Right? You can do that all based on a rule system. Order facts. Stuff is just regular stuff. Database records. It could be an API feed, JSON, CSV, Excel. It seems every industry I've worked in for the last 20 years, people really just want a fancier front end on Excel. I don't know why that is, but it's definitely the case. So rules are just if-then statements. If this, do that. Nothing. There's no real rocket science in this whole presentation. It's all pretty straightforward stuff. The key thing is a rule matches some attribute of your fact, and then you can do stuff with that. So you can say, in a simple example, we stopped as soon as we figured out it's a bird or a mammal, right? Done. So we just stopped. Or you can modify or add facts and keep going. Or you can change what happens next. So as I described, you could tell the engine, hey, I figured out it's a bird, but I now have 20,000 rules of different kinds of birds. I don't want to run through all of those plus my 100,000 mammal rules. So you could tell the engine, prioritize bird rules, or turn off all the mammal rules, because why waste compute plowing through all these rules that aren't going to match? So the inference engines give you these, they give you priorities on and off. And the real fancy ones, there are a million algorithms. In for the pay-to-play versions of inference engines, you have all sorts of top secret algorithms. And the key thing here is how to organize the rules and facts so that you can look up this stuff really fast. Because if you have 1,000, if you have 10,000 of either facts or rules, how are you going to match those in milliseconds? It's a hard problem to do that many comparisons. So the key algorithm out of this is called a READ algorithm, and basically it builds a directed acyclic graph of all your if statements, right? So if you have a bunch of statements that are like, if it's a bird and its feathers are blue, it's a blue jay. If it's a bird and its feathers are red, it's a cardinal. And you have like 1,000 of those. You can imagine building a tree of if statement, just a big decision tree, right? Is it a bird? Go down this side. Is its feather color red? Go down this side, and so on. So you can build this tree ahead of time, and then all your if statement lookups just take you to a different part of the tree. And in fact, you can place your facts against it, and you'll know at any point which facts to even look at. So you don't have to look at 10,000 facts. So that's what all the cool kids are doing. We're not doing that. We're going to look at I'm using a really simple I needed a JavaScript version, and I just wanted to solve one little fun problem. And so this is how node rules, the JavaScript implementation works. It's the simplest possible one. And you could see my slide software didn't have the greatest line drawing algorithm, but well, we should be able to figure this out. So we got facts. We apply a rule, the first rule, to it, and we say, hey, does that rule match? No. If it's the last rule, we're done. Otherwise, we go back and grab the next rule, apply it to the facts, and we keep going until we finally get a rule that matches. And does the rule say, hey, you're done, then we go and we say, and here's the result. It's a bird. Woohoo, success, right? If it gets to it and it says, it's a bird, but I'm not the end rule to apply. You can keep working. Then what this engine does is says, oh, you've asserted a new fact that this animal's a bird. So what it does is it restarts all the rules it just goes back to the beginning and say, okay, now that you know it's a bird, let's start going through the rules again and see what matches and see if we can figure out anything more. So it's really in some ways the dumbest possible implementation, right? Check a rule. If it matches, assert something new, start back at the top, keep applying rules. And eventually you won't change the world of facts anymore. And you just pop out to the bottom, you hit the last rule, and you're like, okay, I got nothing more to do. And then it tells you, here's the new state of the world. We know it's a bird. That's all I could figure out for you, that this is a bird. Okay. But this whole thing is like 60 lines of code. This rule engine is a really simple little rule engine. And so that's what appealed to me about it. That was pretty cool. So there's no Steve presentation that doesn't involve dog agility. This is my hobby that I do with my dogs. So I always have a presentation that has something to do with dog agility. So I'll give you the primer on dog agility here. Basically, dog agility it's an obstacle course for people and their dogs. You never know what the course is going to be. You just show up. The judges laid it out according to certain requirements. It's a timed event. The dog can't drop any bars, or you have to take all the obstacles in the prescribed way. And it's timed, so fastest wins. And basically what I was looking to do was solve a problem in the calculation of points. Yeah, that's my boy. This is my dog Flyer. This is his retirement run. We're actually, this is 2019 Nationals, and he's a veteran in this. He's in the veteran category, and we won it all. So that was pretty cool. But we get to stand on a box and get a ribbon. So that makes it all worthwhile, the thousands of dollars we pay for our hobbies. So that's what it's all about. So what was I? Oh no, we've seen that enough. Thank you. Oh, come on, slideshow. There we go. So the question I'm trying to answer with the rule-based system is, are we qualified? So what that means in this world is, each time you go to one of these competitions, you pass or fail. So they call it qualifying or not qualifying. So the question is like, did you queue today? So did you qualify? It's called a queue. And basically, when you first start out, you start out at the easiest possible level. You do enough successful runs, and you get to go to a higher level. The courses are more difficult, and so on and so forth. And the thing I wanted to do was figure out how to calculate titles, because people are always forgetting. In some organizations, you can't stay at a low level once you've reached a certain number of qualifications, because you're taking scores away from other people. It's like any sport, the rules get stupidly complicated for no good reason. But what we're trying to do is figure out, can I get to nationals? Can I get to the invitational? Have we got enough points? Have we done enough things in the qualifying period to get to the big show? That's what everyone's trying to figure out. You would think that nowadays, why isn't this stuff just on their website? No, it's dog sports. Nothing's on the freaking website. You're lucky to get an email. You get, like, once a month, you'll get an update that says, Sparky got his new title. Here's a certificate you can print out. I'm like, okay, thanks. Thank you so much. The rules change every year to go to nationals. They're always monkeying with the rules to see who can get in and who can't get in. And so people always get confused. So that's the problem I'm solving. Why rules? Because as you'll see, they're really simple and they're easy to apply. So here's 2 different organizations. I compete in 3 different organizations with my dogs. The AKC is probably the club you've heard of, or AKC dog shows. Basically, they have a very simple approach. When you see dog shows on TV, where the pretty-looking dogs, those are all AKC. That's the same organization, just so you know. Basically, you start a novice, good name. You get 3 qualifying scores from 2 different judges. You move to open. The same rule applies to go to excellent. The same rule goes to masters. And you spend the rest of your life in masters, collecting points. And once you're in masters, those points qualifiers let you go to the national competition if you get enough of them. And that's the simple case. UKI is crazy complicated because you have to beat people, and when you beat people, you get more points. If you compete against more people and beat more people, you get even more points. And they have multiple games, and you have to combine them. I'm not going to take you through the complexity of that. We'll just look at how rules work to do this simple one of moving between these guys. So what are our facts here? Our facts are just what everyone records. Each time I go to a trial, I have a fancy spreadsheet. I keep everything in, although I'm probably going to write an app that lets me do all this stuff, which is why I'm investigating this. You date it. What's your dog's name? What organization? What level? Did you queue or didn't you queue? Did you get points? And who is the judge? As you could see from that previous chart, I kind of got to keep track of which judge gave me the cue. So let's talk about facts. Here's what a fact looks like in this node rules stuff. Let me focus on it. So there's an array of, you guys can see this okay? There's an array of each run that we take, right? So it's got that same data you saw in the previous slide. Did we queue or not? What level? Who is the judge? And then what titles have we earned? So right now, let's pretend Snap here has no titles yet, and I just have all his runs recorded, and we want to see how far did Snap get, right? So this is a set of facts. And what's a rule look like? So here's that first rule that I showed in the slide. You can give it a name, and then you say, okay, what's the condition? So it's basically just a plain old function. You know, these are really simple to do. I have some helpers, but what we care about, let me back up. So there's a function. These functions are called with 2 things: the facts, the list of facts, and this thing called R, which is basically the engine itself, the inference engine's API. So you give it, this is like old school C-style programming. It's very functional. You hand everything, no objects, hand everything in. So you basically say, hey, engine, when I don't yet have a novice title, but I have 3 or more queues, and they're from two or more judges, what should I do? Then it calls the consequence function, hands in that same data, and I say, hey, push the novice title into the AKC titles bucket. So I've changed the world, and then I call the API and say, hey, r.next basically says, I updated the world, rerun all the rules again. So in this rule engine, you're the engine. You control the engine completely. You say, match this. What should the engine do next? You could say r.stop, and it would be like, okay, that you had a result. The result was this title's got NA in it now. That's how dead simple it is to write these rules. And so when you look at it, you could probably even write this in a way that a non-programmer could possibly understand it. I have these simple little helpers down here, which you would know how to write these in 5 minutes, given the data structures I've given you. There's nothing fancy about this. So how do we run this thing? So I wrote a simple Node script. I've never written Node before. I'm a regular front-end guy. I'm not a back-end guy, but it turned out to not be hard. We got our facts from before about Snap. We took that rule I showed you, throw it into an array of all the rules, and you just instantiate this rule engine with the rules, and then you say, okay, do it, and do it with these facts, and it just runs, and when it gets to the end, it prints out the results, and sure enough, Snap has his NA. So this is the kind of thing where you could instantiate this rule set. You could define the rules once, just keep feeding it facts, right? I could have this on a website. People could upload their runs, and I would say, oh, Fluffy is in Masters, and Sparky is in Open, or whatever this story is. Or you've qualified for Nationals. You have not yet qualified for Nationals. What it doesn't tell you, though, is what more do I need to get to Nationals, right? It only goes forward. There's the notion that I'm not going to talk about backward chaining, which is where you can say, if I want this to be true, work through the rules backwards and tell me what needs to be in my facts for me to be able to achieve that goal. So there are different sets of expert systems that do both forward and backward chaining. Backward chaining is more complicated. So that was the fun. Let's talk about profit. Okay, I promised you profit. So I came up with this idea, and I found in GitHub a Vue 3 app with using Pina for the state management. So it's like Redux if you're not a Vue person. It's basically just a simple Redux style store. It's called Vue Cart. Excuse me. Let me get some water. And basically, I just modified it so that I could do free shipping or give you some discounts based on what the date is. So it's kind of some basic rules your folks might have if you had a promotions team running your e-commerce site. Well, let me show you what it looks like. So it's basically, just a little store. It's got a cart. You can add stuff to the cart. And I modified it so it just shows, it's $10 shipping. It's always $10 shipping, right? This is like the simplest possible demo I could whoop up, right? So let's clear our cart. So let's look at this code, because we are supposed to talk about code a little bit here. So it's a basic Vue app. It's got, big enough. It's got some components, some composables, pages, and then at the top level. So it basically uses Composition API. If you're familiar with Vue 3 or React, it's the same kind of style for the Composition API. So you can get a store out of the state management. There's two stores in this thing, the products and the shopping cart. And basically there's a lifecycle event called onMounted you can call, and I use that to initialize everything. So we fetch all the products. We initialize the rules it needs the cart, so we can know when you're adding and removing stuff, and I'll show you that in a second. And then the interesting feature of Pina is it has a global subscribe list callback on it. So anytime anything happens to the cart, it's going to call this callback. And what am I doing? I'm just going to rerun all my rules and see, oh, did they get a discount? Did they get free shipping? That's how that works. So let's look at the cart. So the cart, it just had purchases in it before, and I just packed it to have shipping, a little message, and then some discount percentage and a discount message. And I default them. And then I added so that I could calculate the subtotal of the grand total easily. Simple stuff. The cart just has a whole slew of hide and show lines in that cart. That's what gives you those subtotals. Nothing magical here. On the home, I have, if their discount is in effect, I show it on the top banner. I'll show you that. So let's look at the rules. So this should look pretty familiar to that other example. Here's our function where we call it with the store, the cart store. We say, hey, let's initialize the rules when we start up. I hold on to a pointer, as it were, to the store, reference to the store. And then so I could run this at a few different times. I'm just saying today is Valentine's Day. So I'm just hard coding the date for demo purposes. And then we've got an array of rules. And this should look very similar to what you saw before, right? I just initialize the engine with the rules. And when the cart is ever updated, this guy gets called, and we say, hey, execute it using this, using the store itself is your data source. That's the facts. So instead of having a separate array of facts, I'm using the data store itself as the source of truth, because it is the source of truth. And then when it's done, I just log some stuff to the console. But you'll also see the app will update too. So let's look at the rules. Let's turn on a rule that enables free shipping. Everybody likes free shipping. And same concept, you give it a name. The condition is when they've purchased more than one thing, and the price is less than $100, let's put a message that says, hey, if you just spend $100, you'll get free shipping. All right. And I set the shipping to $10. And I say, run the next message. Run the rules again. I'm updating the store directly. No fax, no other stuff. Just pound it into the store directly. And then there's another rule that says, hey, when there's more than one thing in this, when you've got more than one thing in your cart and it's $100 or more, you get free shipping, and shipping gets pounded down to $0. Should work. Can't possibly fail. Can't possibly fail. One thing I noticed though is hot module reloading really screws with this, so I have to hard refresh it, but we wouldn't have the problem. So it has run through, because when I fire it up, I run the rules first thing, and it says, hey, shipping's still $10, no messages, nothing's going on. So I don't know, let's add something to the cart. It ran again, and we figured out that there's one thing in the cart, shipping's still $10, but the message in the cart should say something clever. Yep, free shipping on orders over $100. Clearly, I'm not promoting this well enough, but I have to work on my design skills a little bit, right? So let's add more to the cart, and as soon as it triggers, it breaks $100, that other rule fires. And you can see each time it's running, I'm dumping the output. So dead simple to do, and hopefully if I go down, yes, shipping pops back, and so I'm a power user of forward chaining right now, apparently. Okay, so, but I was actually, I'm kind of making light of it, but it's like, hey, that's pretty cool, actually, there really isn't much code, and you can imagine a world where this is done by someone who isn't a hardcore developer. And some of the other rule engines have domain-specific languages where you write in their lingo, these rules, so that you could train someone to use it and not have to understand the weirdnesses of JavaScript to do it. And that's where the real benefit is then you don't have to be on the dev team doesn't have to do these dopey rule changes every time marketing decides, oh, we've got to ship these green t-shirts. We got to unload this warehouse. So let's look at our Valentine's Day one. I've in all the excitement, I've forgotten what my thing was here. So I think I've got one here. It says, okay, if it's on the 14th, we will say, hey, happy Valentine's Day, 14% off purchases over $100. And I've got another one here. If it's Valentine's Day and it's over $100, you get 14% off. So you actually do the work as opposed to just tell them about it. And then if the dollar amount goes below $100, we take the discount away. That's the only bummers. You'd kind of like it to just have one rule and it would auto reset. I'm sure someone smarter than me could come up with a way to do that. So let me refresh just to make sure no weirdnesses happen. So let's go to our home page. And so, right, my date was hard-coded to the 14th. That is the precursor to all this. You may have forgotten that. So the rules ran, hey, 14, cool. So let's spend over $100 right away. So not only do I get my discount, but our shipping is also still free because it's also, that rule is still running for orders over $100 if I take it away, so we can test those separately. So I'm not over my magic number yet. So I can get them both at the same time. It's kind of boring. It's not that exciting. But but once again, so you can keep combining these rules. Yeah, I could have coded this so you only get one of them, right? If I said rule engine stop as soon as you get a match, I'd only get whichever priority I wanted to give them. So that's where giving you control of the engine is pretty powerful. Yeah, I mean, because we're storing, we know it depends what you want to store in your state, right? So if you kept it in your state, what the discount amount was, you can easily add it to a rule, because that's the beauty of the rule thing, is you can keep adding state and use that. Actually, it would have been such a better example than my example. Is because the whole goal of this is you're modifying the world, and then you can use those modifications to deduce further things. You could say, oh, he's got more discounts than he actually has products. You'd probably want a rule that would keep that from happening, right? If there's you can imagine someone coming up with a set of rules where you spend $200 and you get $300 off. That would be bad, So that's how. I think that's all. I had one more example, but it's basically the same example. So let's go back to here and here. Cool. So there's a number of JavaScript implementations out here. New Rules, which is a pretty good name. JSON Rules Engine, JS Rules Engine. These have a lot more features. They have some DSL, domain specific language style approaches. Node Rules was just so easy. It's really, here's the execute function. It copies all the facts. It defines the API, which is those next, stop methods. And then all it does is say, are we at the end of the rules and we're not done? Get the condition and execute it. So it basically says, if this thing is true, run it. It just says run it and just calls it. And you saw in the condition clauses, you decide what happens next. So by saying r.next, I say, okay, we'll restart the rules and execute the next rule that matches. So you just basically it's like using a set timer to just queue up the next thing to do. Anytime you get a match, you tell the engine, queue up the next thing. It's like, okay, I'll do it. And that's all this is. It's brilliantly dumb. And I guess in Node world, there's this notion of process next tick, which is, since I guess it's got a big async loop, I think is how Node works. It basically queues up the next thing. It works just like set timeout works. You have set timeout, so it's the same concept. So I saw this, I was like, I actually totally comprehend how all this code works. This is a great little library. So that's why I chose it. I didn't need anything fancy, as you could see. These are the more famous guys. Rules and Clips have been around forever. They're the big players. Microsoft now has this rules engine one in C#. Very exciting for some folks. And that, I think, is all I've got. So there we go. Thanks, gang. Any questions? You guys all ready to use rule engines for all your coding? Yeah, you don't. I mean, that's kind of the argument for breaking them out into a separate world, is then you could push the inputs and check the outputs for all the things you care about.
Your graph is complicated enough for what you back something else and all of these stuff for balance and that's what you do. But those have to become
yeah, you could certainly have circuit breaker rules in there that always run and check. Did we give more of a discount than they ordered, or is it more than a certain amount, or any kind of checks? It's the same kind of thing, because people are using these expert systems for diagnosing cancers and all sorts of life-changing stuff, and someone's validating those. So it's exactly like Prolog. That's how Prolog works. It's exactly the same thing. That's actually when I was in grad school, I used Prolog for one of my projects. So.
Based on like certain rules that follow the thing like, yep, you can be a node
Yeah, it's very good. I didn't look. This was something that I dreamt up like a year ago, and when I heard we were having a meeting, I was like, "Oh, I think I got something," and I don't recall what I found for backward chaining because I do want to put that qualification thing into a website or into a little app for other dog agility people. And they're gonna as soon as they get it, they're gonna say, "Can't you tell me what I need to do to go to the finals? To go to the nationals?" And so you're right. Yeah, back chaining is pay me, pay me, and I could wasn't it Zappos where the guy went to Payless and bought shoes and sent them to people before he even had a warehouse? I think it was the Zappos guy. I could do the same thing. Pay me and I'll tell you what you need before I write the software. I could backward chain for $20 a request. I could do it. I'm a smart guy. I know the rules. Yeah, I could outsource it. Yeah. Cool. Thanks, guys.